All right, good morning, students. I'm away at a training, and so this is your review for the warm-up for day 137. So, we can see for a transverse wave, our amplitude and our wavelength goes from crest to crest or from trough to trough. How do we do with a longitudinal wave? Now, we have the same things here, except instead of peaks, we have compressions, and instead of troughs, we have rarefactions. So compressions, think of if you squished a spring, it would have a lot of energy, boing, to expand like that. That's what the compression is, just like a peak is a lot of energy as a wave goes by. So we've got those here, compressions, rarefactions, those are our terms, you should have those in your notes. And from where to where could you measure wavelength? From compression to compression, or from rarefaction to rarefaction. Checking our understanding. So the wavelength in this diagram up here would be A. All right. B would be twice the amplitude. E would be half a wavelength. C is also half a wavelength. D is an amplitude. Number 2, the amplitude is given by letter D. B, by the way, is 2 amplitudes, right? From the equilibrium point to the highest and to the lowest is twice the amplitude. And then for number 3, the interval that reflects a full wavelength. Well, a full wavelength goes from the same point to the same point on the wave. Like, so if you went from B to F, that'd be a wavelength, or from A to E, a wavelength. But those aren't on here. So the only thing that's on here that is actually a whole wavelength is from C to G, right? From where it goes down to where it goes down on the same point again. All right. For today, you'll be working on this. You have a physical copy. That's right, a physical copy, actual paper in your room or in the classroom on my desk. And so what you'll see is a crossword. This should take you probably about 10 to 15 minutes tops. And then some more math practice. You've got 2 equations here. You want to use this equation on the right. Velocity is distance over time when you want to know how fast the wave is traveling. And velocity equals wavelength times frequency when you want to know frequency, wavelength, or speed given those wave-like terms. So that's the deal. All right, all the problems are there, and good luck. Have a great day. See you tomorrow for the quiz.